All right, sixth grade. So this week we're actually going to start lesson 26, which has to do with inequalities. So for the last few weeks, you've been talking about positive and negative integers, whether that was comparing those, whether that was adding or subtracting those using number lines, or on Thursday of last week, we looked at those and you used either the positive or the negative chips, or like I said, if you didn't have those, you could draw circles to compare those numbers. So we're using what you've already learned and we're going to take that knowledge and move forward. So our targets for today, we are going to be looking at inequalities and trying to figure out, okay, what can we do to make a inequality true, a specified set of numbers. And we're also going to look at some certain symbols that we use for inequalities. So you may be asking yourself, I've heard that word inequality, but I really don't know what it is. So here on this page, I have some symbols that you may be used to when looking at inequalities. So just to refresh your mind, I want to go ahead and use, we'll use purple for this. So this symbol is the less than symbol. Okay, and you probably have that somewhere in your room, in your classroom to use. So if it is on an anchor chart, definitely can use that. You're also going to have access to this video where you can go back and look at this as well. So if this is less than, then the opposite of that will be greater than. And I probably should have typed for this because it's taking a minute. Okay, so as I finish greater than, you're going to see to the right of this less than and greater than symbols, you have this particular symbol and this particular symbol. Okay, so the first, which is right here, this symbol looks like the less than. So it actually, we are going to say it is less than, but it also has a line underneath it. And that's basically half of an equal sign. So this symbol, whenever you see it, means less than or equal to. Okay. With that being said, this symbol looks very similar to this. You have that greater than symbol. And you can probably guess from now that it also has half of an equal sign. So that means it is greater than or equal to. Okay, that's what that symbol represents. Now, we have two other words here at the top. Inequality is when we are comparing numbers using the symbols that are here at the bottom. So whenever you use less than or equal to, greater than or greater than or equal to, that is using an inequality because you're comparing more than one number. Okay, you're comparing more than one value in an expression. The word variable up here, variable is when you have a letter or symbol that represents a number. So I'm going to go ahead, just in case you need to know that information for later. And I am going to type that out. A letter or symbol that represents a number. So it represents a certain value. And I am going to move that right here so you'll know that that's what that is equal to. Okay. All right. So we have the definitions kind of out of the way. So now we're going to move into session 1, and this is in your math book. So if you do not have your math book out, you need to pause this video, and everyone will need to get out your second math book. So volume 2, page 583. So again, page 583 in your volume 2 math book. So go ahead and do that if you haven't already. All right. So, with our first problem with comparing inequalities, we have a picture right over here of a thermostat. Okay. And so, if you didn't know what a thermostat is, a thermostat is what you use to control the air conditioner or the heat in your house. So, this particular problem, the thermostat in an office is set to turn the heat on anytime the temperature drops below 15 degrees Celsius. So let's think about this problem. We have a thermostat. It's set to turn the heat on anytime the temperature drops below 15 degrees Celsius. That's probably pretty important. And that the heat turns on. Okay. And actually, I'm going to underline drops. Okay, that's our verb there. It's going to drop 15 degrees Celsius. So, think about that for a minute. Think about some temperatures that the office could drop to before the heater turns on. Think about that for a minute. Okay. So, I want you right now on page 300, or excuse me, not 300, 583, and I want you to jot down a couple of temperatures that could work here. What are some temperatures where the heat will turn on? And I'm going to give you just a second, and you can pause this if you need to have more time to write. So I'm going to go back and underline drops below 15 degrees Celsius. So you should have written or um, drawn out some temperatures that are below 15 degrees Celsius. So some possible answers may be 14 degrees. Okay, and I'm going to put this, even though that's not the exact symbol for degrees, I'm going to put that. So, actually, I'll put the word 14 degrees could work. 13 degrees could work, 12, and so on. I'm going to go ahead and put 5 degrees because that could work as well. Okay. What about 0 degrees? Is there a number below 0? Sure. Anything negative could work too. So what if I put negative 5 degrees? I hope it doesn't get that cold in their office, but that could work. Those are possible solutions. And I'm actually going to put that right here. So possible answers. Okay. So now, use words, symbols, or pictures to describe all the temperatures. So these are some answers that could have worked. Anything that you put that is below 15 degrees could work. Okay. You may, if you wanted to draw a picture, you could always draw a number line. I'm going to try to make this straight. And anytime I'm dealing with temperature, I'll just go ahead and tell you, I use a vertical number line just because a thermometer is typically vertical. It's typically up and down. So that's what I would do there. Um, so anything below 15 degrees. So if, let's say, this is 16, I just made up that number. You could have put 20 there. You could have put any number. If this is 15, and I'm not going to do every whole number below, but I am going to put some tick marks, and you'll know that everything this direction is below is less than 16. So it could be anything that is below 15. So that would be any of these values right here, correct? So, and it could keep going on because we know that it's a straight line and it goes forever in both directions. So anything that is less than 15 degrees, that heat's going to turn on. Okay. So with that being said, what are different ways to describe all the temperatures at which the heat is on? So now you're on page 584. And what would work there? Okay, so any temperature that is less than 15 degrees. That could work. Okay. Now, what about equal to 15? Would that work? If we go back to the problem, let me go back up a slide or two. So drops below 15 degrees. So that means 15 degrees itself would not work. So I'm going to actually add to this and say any temperature that's less than 50 degrees, but not equal to 15 degrees. Because the heat is not going to turn on unless it is below. Okay. So any temperature below 15 degrees would work there. All right. Number 2. So again, you're on page 584. Looking ahead, you can describe a range of values using an inequality with a variable. So again, those are the two words that we saw on one of the first slides. We saw the word inequality, we saw the word variable, and then we also saw the 4 symbols that make up an inequality. So instead of saying, okay, any number that is less than 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, you're missing a lot of numbers because think about all of the numbers that you can think of right on top of your head that are between 10 and 11 degrees. Okay. 10 and 1/10, 10 and 2/10, 10 and 3/10. We could keep going. And then obviously there are numbers in between 10 and 1/10 and 10 and 2/10. So there's an infinite number of answers that would work for that. So inequalities help us because they tell us everything less than or greater than can work by using a symbol. So let's look. All values greater than 10 can be used or can be represented with x is greater than 10. And again, if you need to remind yourself what those symbols mean, you can go back to the slide that has those. So this is equal. I'm going to box this in purple all together. So all values greater than 10, and x is just a variable that represents any number greater than 10. Okay, so with that being said, any value less than 3, so less than 3, and we just use a as an example, it could be any letter. So any number or any value less than 3 could be represented by A, or it could be B is less than 3. It could say X is less than 3. The letter itself doesn't matter, okay? But a given letter less than 3 is what this means. Okay, so let's look at number 2A. Circle each value of n that makes the inequality n is greater than 2 a true statement. So any of these that are greater than, because that symbol means greater than 2. So I'm going to pause and I want you to go ahead and do that. And if there is a teacher in the room, go ahead and pause the video for a second. And I want everyone to answer 2A. Okay, you're probably finished with the inequality n is greater than 2. We're trying to figure out anything that could be the value of n. So anything greater than 2. So let's go through our numbers here. So on a number line, I'm actually going to use the number line here below our problem for 2a. If I'm looking at the number 2, so I'm looking at this number right here. So anything less than would be to the left, greater than to the right. And let me show you a little trick. This symbol right here, that symbol, okay? If I look at my arrows on either side, okay, this looks like that particular direction. It's pointing to the right. So that is this particular symbol, okay, which is going to be representing greater than. So n is greater than 2. That's going to be anything greater than 2. Anything in this direction. So would -2 work? Is that greater than 2? No, it's not. So that would not work. I would not circle that. -1 and 1/2. That's going to be halfway between -1 and -2 right here. Would that work? No, because it's less than. 0. Would 0 work? Is 0 greater than 2? Nope, it's not in that purple area, is it? Now, would 2 work? Is 2 greater than 2? It is not. 2 is equal to 2, isn't it? 2 is equal to 2. So that one could not work. 2 and 5/10, same thing as 2 and a half. That would be halfway between 2 and 3. Would that work? Yes, it would. It is greater than 2. Is 5 greater than 2? It is. What about 6? Would that work? It is greater. And 7.5 is halfway between 7 and 8. So that would work too. Those are all examples of numbers that are greater than 2. So I am going to actually erase this here because I don't want that to mess us up on the next problem. Okay, so now when I'm looking at 2b, a solution of an inequality. So there is another vocabulary term. A solution of an inequality is a value of a variable that makes the inequality true. Graph the solution of n is greater than 2 that you found in problem 2a. All right. So what this is saying is that I want you to graph those points on the number line. It's all that it's saying there. Graph those points. So 2 and 5/10, it's positive. So it's going to be to the right of 0. It's halfway between 2 and 3. So that's going to go right here. 5 is right here on the number 5. I'm going to graph the number 6. It is right here. 7 and 1/2 going to the whole number 7, and it's halfway between 7 and 8. Okay, so that is what you should have for problem 2b on page 584. Okay, we're going to continue. And again, if you need to pause at any point, go ahead and pause the video to get caught up. Continuing problem number 2 on page 584, you can describe a range of values using an inequality with a variable. Okay, so again, all values greater than 10 would be this. X is greater than 10 is what we had before. Any value less than 3 is A is less than 3. Okay, so let's look at letter C. It says, name 3 more solutions of the inequality n is greater than 2. So before we had the numbers 2 and 5/10, 5, 6, and 7 and 1/2. So I want to come up with 3 more examples that could work here. So I'm going to use some purple. So a number between 6 and 7/10. There are many, an infinite number, honestly, of numbers between 6 and 7. Okay, I am going to use, though, the number 6 and 1/2. It's halfway between 6 and 7. Your answer may look different than mine. I could have 6 and 1/10. I could have 6 and 2/10. Many examples there, an infinite number. So a number less than 4, but still has to be greater than 2. Less than 4, I'm going to go for the number 3. It's less than 4 and greater than 2. Okay, so now a number greater than 8. Number greater than 8, I am going to give the number 9. Okay, so let's go to D. What would your number line in problem B look like if you graphed all the solutions of n is greater than 2? So I'm going to pause right here, and I want you to write your answer for 2D. Okay, I'm going to actually go back to the number line before. So if I graphed everything between 6 and 7, what would be happening here? Yeah, all my dots would be running together. If I graphed everything greater than 9, it would be going together. And think about all the numbers that are off this number line. The number 20, the number 500, and 1,000,000, they're all greater than 9. They're all greater than 2. So think about all of the dots that would run together. It would actually look like a line, wouldn't it? It would look like a line for every value to the right of 2, and it would have to go on forever and ever and ever, even numbers that are off this number line. Okay? So that brings us to a reflection question. There is no limit to how many solutions you could list for n is greater than 2. There are infinitely many solutions. That means that the number keeps going on forever and ever. Explain why the equation t equals 15 has one solution, but the inequality t is less than 15 has infinitely many solutions. So again, this particular inequality that we've been looking at has an infinite number, an infinitely many solution. This has one solution, t equals 15. But the inequality t is less than 15 has infinitely. Why is that? I'm going to pause here and let you write your reflection, and then you can discuss as a class. So as you were completing this, you probably said that, well, t is equal to 15. There's only one solution there because there's only one number equal to 15. Okay, 15 is the only number that's equal to 15. And here, t is less than 15. You can come up with many, many solutions. You can name all the whole numbers that are less than 15. You can say 0 is less than 15. You can say all the negative numbers you can think of. But just think the number line keeps going on forever and ever. And you can also think of all the decimals and fractions that are between those whole numbers that you came up with. So you're going to learn more about how to show that on a graph a little later. Okay, so now let's look at our graphic organizer on page 585. We have our key vocabulary word here in the middle, inequality. Okay, so when I'm trying to figure out what does that word actually mean, what is it? Okay, so an inequality compares values, okay? And I would say two values, but sometimes it's more than two values. So inequality compares values. And we can give some examples. Here you can come up, let's say, with at least 4 examples of an inequality. I will share a couple right here, then you go ahead and come up with some. I'm going to start with 5 is greater than 2. I'm going to say 3 is less than 9. And I'm also going to say that -4 is less than 0. Okay. So again, you can come up with some of your own examples there. And I've used whole numbers. You can add decimals, you can add fractions as well. When I go to the top right, what I know about it, I want you to write what you know. That could be the definitions of those symbols. It could mean something about what you learned on your number line that we just did. And the bottom right, more examples. So we can add some examples with units. So again, I'm going to give you one example. You can come up with some more. If I said that 3 feet, that's a unit of measure, is less than 5 and 5/10 feet. Okay, that would work there. So come up with at least 3 more examples there of inequalities. And when you're finished with that, you can move on to the next slide. So here, what you need to do in your student workbook, you need to complete page 586. you have just a couple of problems there to do. And then you need to work on any teacher assigned lessons in Ready. I know you had some assignments last week that most of you have not finished. So look at your teacher assigned lessons. And if you are finished with those, then you can work on your iReady pathway lessons. Okay, thank you so much. And I hope that you have a great rest of your day. And we will talk more about inequalities another day.